Hi guys, I thought I would start teaching you guys a couple of the topics that we skipped in regular calculus that we will absolutely need for BC Calc. And the first topic is derivatives of inverse trig functions. And the only three trig functions that you will be finding in BC, the derivatives of, are sine, inverse cosine, and inverse tangent. You should not be seeing inverse secant, cosecant, or cotangent. I've never seen them be asked, maybe for practice, but never on the actual AP exams that have been released. So they're just not used, because why would you kind of use them when you can use sine, cosine, and tangent, which are so much more familiar? And remember that the same thing as the inverse notation is the word arc. So if you see arc sine of x, that means inverse sine of x. The same thing as arc cosine and arc tangent. So you'll see those interchanged. Just depends on what worksheet you're using or what teacher's teaching it or how the AP wants to show you it, but they are interchangeable. So the first thing that we're going to do is remind you that this notation, the inverse notation, we put in the value and we're looking for the angle. So instead of using theta, I used y because y and x are so nice to see visually, and we've been using dy dx a lot and not d theta dx. So I stuck with y instead of theta. But just like at the beginning of the year, last year, I would give you guys a problem like this. And I would say, give me the angle where sine is a half. And you guys would say either 30 degrees or pi over 6, or also there's the angle in the second quadrant also. So that's what we're discussing here. So this notation down here, where, no, we don't want to clear the canvas. This notation with the inverse is the same exact meaning as sine y equals x, because one is saying the sine of the angle gives me the value, and the other one says the inverse of that value for sine gives me the angle. So they are different visual notations, but really the same meaning. So since we're trying, I'm going to try to prove to you, well, I'm not going to try, I'm going to do it. I'm going to prove to you where the derivative for inverse sine comes from. Not that you will ever have to do that on the AP exam, but instead of me just giving you the 3 rules and you wondering how did she get those, I'm going to show you the one for inverse sine. And then if you would like, you could go through and do cosine and tangent, but you'll never be required to do that, at least for the AP. But I didn't want to just give you the equations and be like, oh, here they are. So the one thing I want to start with is, instead of using inverse sine of x equals y, I'm trying to prove that. Well, I can't prove it by using it. So I'm going to rewrite it in the form that I know, which is sine y equals x. Okay? So what I did here on purpose was I put an angle down here, labeled it y, and made the sine of that angle equal x. So opposite over hypotenuse gives me x over 1 or x. So I forced the sine of the y to equal x. And if I were proving inverse cosine derivative, I would have done the same thing. I would have made the cosine of y be x. Okay? So I'm starting out with what I want visually. And this down here in red is what I would get from the Pythagorean theorem. If I said 1 squared equals x squared plus, if I let this be b, plus b squared, then I would get b to be the square root of 1 minus x squared. So instead of using 2 variables, I'm just doing it so that I can use 1 variable. Okay, so let me erase that. So I left that in red just so you could see that that's where I got that from. Okay, so what we're going to do to prove this is kind of cool, is if these two statements or equations mean the same thing, I know how to take the derivative of the sine of y, but be careful because it's a function of y with respect to x. So the derivative of sine is cosine y, dy dx, your implicit, equals 1. Divide both sides by dy dx, and we get 1 over the cosine of y. And the cosine of y is adjacent, which is in red here, over hypotenuse, which is 1. So it's really just the adjacent. So what you just found actually is the derivative of inverse sine of x. That is the derivative for the inverse sine of x. And we found it by doing implicit differentiation of the sine of y equals x to avoid using that inverse notation since we're proving that derivative. Hopefully that makes a little bit of sense. Again, we took implicit differentiation. Sine of y is cosine of y dy dx. Derivative of x is 1. Divide out the cosine. And then over here, I want the cosine of y. So I'm looking for the ratio of the adjacent over the hypotenuse, which would just be radical 1 minus x squared. So now you can memorize. You'll never have to see that proof again. I mean, you may see it, but not for BC. Now you can just memorize that the derivative of inverse sine is 1 over 1 minus x squared. Okay. So I'm going to move this up. Again, you can pause wherever you'd like. And we're going to write down the derivatives. So the derivative of inverse sine is 1 over the square root of 1 minus x squared. The derivative of inverse cosine, which would actually be found by doing the same thing, meaning, just so you kind of get a grasp of this, I would let the cosine of y equal x, where cosine is adjacent over hypotenuse. And then this missing side would be my radical 1 minus x squared. And if I followed that same process and did implicit differentiation on this, I would get that the derivative of inverse cosine is negative 1 over 1 minus x squared. Funny, well not funny, but interesting and cool, because the derivative of cosine is negative sine. So that's where that negative is coming from. And for tangent, you might as well kind of see that. If I want to say the tangent of y to be x, then opposite over adjacent is tangent, and this would be 1 plus x squared. And again, if I wanted to do the proof of the derivative, I would implicitly derive both sides and then substitute in the value that I needed for the derivative of tangent of y, which would be secant squared, and I will get the derivative for inverse tangent, which is 1 over 1 plus x squared. Kind of interesting. I think so. Okay. So this looks like it says the same thing because it does. It's not supposed to. It's supposed to have an f of x here. So this is a very basic derivative because the derivative of x is 1. There's no composition of functions like we would apply a chain rule. But a lot of times at the AP level, you are going to actually get a chain rule within an inverse trig derivative. And they're actually not that bad. You just have to remember to apply the chain rule, which I have to remember anyway for any composition of functions. So if we take a look here, the derivative would be 1 over root of 1 minus squared. So that's the derivative of the outside times the derivative of the inside times f prime of x. That's your chain rule. Cosine negative 1 over 1 minus f of x squared times f prime of x. Again, that's your chain rule. It will be much, much easier to apply these derivatives as it is the notation is actually or inverse tangent of a function of x. It's 1 over 1 plus that function squared times the derivative of that function. So again, it's just the chain rule being applied. So let's take a look at just a couple examples. Okay, I'll try to get through maybe 3 examples and 3 or 4. Let's see what we can do. If I just give you, this is why you'll see. So if I just give you inverse cosine of x and I want its derivative, then that's all that's testing you on is the basic derivative. Like me saying, what's the derivative of sine? Obviously, it's cosine. So if the AP were going to ask you this, they probably won't ask you something so easy because it's just the most basic, the most basic derivative here, which doesn't actually use much skill, okay? So what they're going to do is they're going to make it just a little bit worse, and they're going to say, find the derivative with respect to x of inverse cosine of 5x. Now you see the composition. The inner function 5x, the outer function, the inverse cosine. So negative 1, we have the basic one memorized, of 1 minus the function squared. Make sure you have parentheses around it. Now times the derivative of that function, which is 5. So we would clean that up a little bit and make it negative 5 over the square root of 1 minus 25x squared, squaring the 5, squaring the x. On the AP exam, if it's a free response, leave the answer like this. You do not need to simplify. Multiple choice, your answers will be simplified. So let's look at an inverse sine and an inverse tangent before we say goodbye. So let's say we had, oh, you know I love me some e's. So if we had inverse sine of e to the 2x, I'm going to do 1 over the square root of 1 minus the function squared times the derivative of this function. And the derivative of e to the 2x is e to the 2x times 2. So again, I can clean it up if I'd like. And powers to powers multiply. So that's e to the 4x. Don't get too lazy and not know how to simplify your work, because 45 questions are multiple choice and 6 are free response. And although they are equivalent in grades, you still have to know how to simplify. So let's look at our last one, inverse tangent of, I don't know, let's say natural log of x. Oh, I didn't even show the derivative notation here. How bad is this? Let's fix this. I'm actually going to stop this video as soon as I fix this notation, and then pick up in the next video with a couple more examples, okay? Thank you.